Tell me. What is the key value? Hash table. Do you understand hash table? Data structure. What's key value? Think of a key, a value. You know, key value. Calling key value. Do you understand key value? What? The example. Give me an example. Key value. You know how to answer that key value? Key value. So Kevin, do you understand key value? By using order, the table order.
Maybe like the primary key.
Primary key. Okay, then
To
value.
value. If you there is the hash table, it may be based on the data you put, and you will generate some a number to point to the data.
Okay, pointed to the data. Okay, and now the order, right? We have the order table, right? Presume we have order number, right? Order number, we have order number, we have customer name, for example. Order number, customer name, and we have order item, right? Well, the order dates, right? We have order dates. It's order, no. So, if I give you order, then what's the key value?
Order number.
Order number is the
Key value.
so we have. So tell me is key value.
Is the pointer. The pointer.
Pointer. No, I said order this.
Order number.
Order number value.
Value is the date, class ID, those things.
Class ID.
Just the rows.
The row. So here, that's key.
Yes.
And value. So anyone can tell me that key value pair? Key value pair. You guys understand that key value pair? Harry?
Sure, I'm right or not, but I think key value in this table's order number is the key, and the value is the in this key include the information like date, cost ID, amounts, tax, total, and payment type is the value of this key.
How many key value pair? If
Six. 6.
Six key value pair, right? Shan, yes?
I think so too.
Yeah, yes.
Yeah, 6.
Key value pair. Yes. Okay. So key value, right? Key value. So for the record, we just sort that order. We have 6 key value pair. And Shan, what's the difference between key value and document?
Sorry, teacher, but I don't know what is the document mean.
It's the one types of non-SQL.
I don't understand that. Sorry.
Do you understand JSON?
Yes,
Okay, explain JSON.
JSON is a data type and is based on the is a
Curly brace.
can I explain on the whiteboard? I don't know what is the simple English.
Which one? It's a curly brace.
大括号
Curly brace.
curly brace. Yes.
Mm.
The JSON is a
You have
data type to using 大括号去to split the data and you can contain to the key and the key have a data. The data
okay,
type
you
can
say
be
key is a data. It says a key value.
a
Key.
key to a key
data.
value.
So you talk about key to the data. Does that means a key to the value?
The key name to a value. And
Alright, so to the data means value.
yes,
Right.
and the value type can be another JSON or an array
Mm.
or a string and
Array?
an int
It's an array.
and float like
Mhm.
this.
Okay, so then you talk about so JSON, right? JSON, you can see a lot of record, right? A lot of record, right? So you wanted to explain a group of record. We put it in JSON, right?
Yes.
And is it necessary to have the same key for each record? Do you understand what I mean?
Same key for each record.
Yeah, so here we just sort order, right? So order relational database, every record should have the same field, right?
Yes.
What about in JSON? Can we have different key?
I think in JSON we can have a same key.
It is necessary to have the same. We have the record, right? Order, right? Order. We have dates. This is 6 pair, right?
Yes.
It's 6 pair. It is necessary that every record has 5, right? We have 6, right? 6. Do you understand that? 6?
I understand. No, not
No.
necessary.
Not necessary. But what about the relational database? We should have that. The same.
We should, but because the hash band should the index of
Relational database. Relational database, if it's order, it means every record should have the same or not.
should have the same.
Should have the same. But JSON,
No.
no. All right. So if you understand JSON, then in this document.
Okay, I understand it.
Okay, so JSON or XML, this documents. All right, so it's quite flexible, very flexible, because when we see the order, every record should have the same. All right, quite rigid, right, rigid. All right, but no SQL. The chain sets, not necessary. We can add, but we can, no, that's different for each record. And each record is a key value, right? So documents is a group of key value. And each record can access on. So you can see how flexible it is. What's a SQL? All right. Then what's column now? Column. Okay, Harry?
Columnar is like you store the data by one columnar is a data. The
One what?
columnar.
This is not column.
Columnar. Sorry. Columnar. One columnar is the data 的单位
Okay.
is the columnars, in my opinion.
Okay. In terms of speed, which one you think that's speedy? Column or document? Kevin, do you understand which one? No. Does anyone know that? Raise your hands. Who knows it? Can search that in. Okay, Alex.
I think the column is a fast, like a Redis memory. The type of the memory is a fastest.
Let's say it again.
I think the columnar is a fastest. Like example is Redis.
Redis. Okay, would you tell me the most famous database for columnar?
Sorry, what do you mean the most?
Famous.
I'm not sure.
Okay, and which one is the most famous document?
Mango.
MongoDB.
Yes.
And which ones that's bigger, can handle bigger data, columnar or document?
Column.
Columnar. Okay, and if you are undergoing a project, right, then you will use columnar or document.
Document.
Why it's going to use document?
Because the project we do have the document, and we need to save us what the project is going to do and what it's going to be. So the document I think is more suitable.
Well, because if you are undergoing a project, usually there's a small to medium size.
Yes.
All right. So MongoDB will be useful for you. Right. So I will encourage you to understand MongoDB. All right. And what is CMS oriented? CMS. The system change, CMS. Content management system. Yeah, we have lots of app, right? We can download it for free, but a lot of it you need to pay. CMS. What is CMS? It's very popular. You may use it. CMS. You know, we said that we have lots of social media. How can we manage social media? Someone wanted to answer this. Social media? Yeah, line, you know. Which ones are going to use to handle social media? Do anyone knows it? Do you understand that? Eric, can you answer this? We have different kinds of, yes, Sean?
So since it's like a WordPress or something, you can make the user programming website or content without know the programming, know how to
Yeah,
program.
well, just at the very beginning we said that social media, right? So social media, we wanted to know you know, someone, you know, that has a lot of fans, and some fans will follow it, right? We wanted to know that which one, you know, is the most popular store, right? And how many person or how many followers, right? They could variable for the one become a hard one, right? It's a lot of followers, right? And we wanted to know the overall, that's how many. I don't want to use the word, because use the word then you know the answer. We wanted to know that if anyone becomes a node, an entity, right? And we wanted to know that how many follow it and their relationship. What about their relationship? Yeah. We have many. Yeah. So it says node 1, node 2. We have many nodes that follow this. And we know it is the most popular. Probably it's by direction, right? What can we do? That's the last type graph. All right. let's see it's key value. Right. So key value, we have key, unique key to our value. Right. So you can see Amazon order a lot of shopping, the shopping cart. So we know which go to the other, right? And key value, that is the basic type, because you're going to see lots of NoSQL database use key value. That's the basic part. Amazon's Dynamo, right? So it's the most popular one. So here, if I give you the question, you should know how to convert it. If I give you a piece of the table, all right? So the table name is a student. Student got a student ID as a primary key, all right? Student ID. And of course, we have many fields. So here, I give you first name, student's first name. I give you student phone number. All right. So I ask you that please convert students into key value. Then you should know how to do it. All right. You have a key and value. What constitutes the key? You should have table name. Students is the table name, all right? And primary key value, not key, but key value. So here we have student ID. You have key value, right? So keys value. So we have key. So student is the table name. Then we know which table and which primary key, all right? So since it's a primary key, it's a unique. You don't specify that. And then we go to, we have two field. So we have two pair. So you should give me this student. All right, key value. All right. It's the first name and value, because that's a string. All right, that's the digits. Phone is value. All right, so key value pair. If I ask you, convert the table, or I tell you, convert the object, the same, to key value. All right. And I said that is the basics. Documents. You can forget everything, but you should remember MongoDB. And I suggest you to use that as your graduate project, right? Because MongoDB, it can handle as a CMS. So you're going to use CMS. So try to run, CMS, right? And adopt MongoDB to process that. It's quite popular. That's document, and CMS is a lot. Some, it's free, some charge. If you wanted to conduct a real-time analytic, or lots of it, so it's very useful, particular for you, right? That is just on XML. So this is just on, right? So I said that's our book. You have lots of book, but they can be different. The key, all right? So they can be different. So you can see that what's Shen said 大括号, all right? So here you can see 大括号, curly brace, C-U-R-L-Y, curly brace, B-R-A-C-E, curly brace, right? So here you see 打括号, right? This is 打括号, right? Curly brace. There's a lot of breaker, but it's quite flexible to that. Then, if I ask you, please convert students, these students to document-oriented syllabus, then you should know how to do it. All right, here we have two records, right? ID, name, just that, right? But because, this is quite easy, quite rigid. Every record should have first name and phone number. But if you conduct JSON, right, it's flexible. It doesn't mean that it should be the same. But here, there's the same. It's very easy, to convert it. Okay. Column or columnar. All right. So let's store data into column instead of row. But you're going to see a row has column. All right. And here, it's a Google's big table, but Meta, that's it. FB, Cassandra, but you probably will not use it because very huge. All right. So most often you use MongoDB. All right. So here it's going to see this. You have a row ID and column. A column is a 3 partition. One is the name and value, and the last one is timestamp. You can use a different timestamp, and here it is Unix timestamp. Right. So it's a column. It's a column store. It contains 2 rows. Right. It's very fast. Graph. Entity with the nodes, their relation. Right. Graph. So graph Neo4j. You can see Neo4j. That's. We can see who follows who. Alright. So presume that is the user 101 follows user 109. It's very easy to know who is the most popular. Actually, you don't need to have a lot of computation because you use this graph database. It's very easy to handle that. So you have an ERD, right? So ERD, from this ERD, then you know how to convert it to relational database, the table. Here, we have to annotate students, course. Student registers many courses. And the course, can be registered by many students. So many to many. So you know the role of this register, right? Then we converted it to relational database. One is student. What about the attributes? Here we can see the same student ID and name, right? So you can see that. And underline as a primary key. Right. So student has 2 attributes or 2 field. All right. And course, all right, course, student ID, and course code. And here you should know that this one, title, right? Title. Sorry for that. So course code is a primary key, and the name of the course. And this one we just talk about. We should have the primary key from 2 tables, right? also register table, register, and also we can see register dates, its own attributes, its own field, right? And these two foreign key we combine it become primary key of register, and then the ERD and also you can see like graph we convert it to a table. Okay, since you know it, then you should know how to deal with that. All right, so it's quite similar. But by using graph, this kind of data store, right, it's very easy, to access some aspects we wanted to know beyond the traditional key value. But here, that's SID. So for example, this one, student ID, and then the name. So also you can see the shadow of key value. The name, Ahmed, alright. And course, alright. So the students take course. So here you can see the course. It's two course, alright. So now we wanted to combine it all together. Course code, title, and register date. Combine that together. Right. So here we can see students, right? Their relation. So register relation. All right. Student register two courses. Student register two courses. This course can be registered by many students. All right. So you only see a piece of it, but here and there, right, and the code. All right. And then when we select a type of databases, all right, key value, that is you should know it. It's the simplest and become the base of other. Right. So the key value pair. If you know a hash map, then you should know the concepts of key value. And documents, right. So I would suggest that MongoDB is the most popular, right, and you will use it and consider CMS to understand CMS, right, because they will speed up your design CMS. Okay, columnar, right, very efficient. It's getting, you can see a row with lots of column. So getting all rows and puts a specific value from each of it. So family database generally useful for CMS, blogging, platform, and lots of apps. So, but it's very, very huge. You probably would not use that. Graph, it's very interesting to know the graph, right? Try it out. Graph. So, well, we have already talked non-functional, right? So what we care, to make your design would be appealed to your audience. That's the non-functional but not functional, right? Because we presume that the same domain should have similar function, but the starting point is the non-function. So like the system can apply to different platform. we search that in a very efficient way. It's available, always available, that 24 hours a day, 7 days a week, right? And we think about that, how quick we can fix the problem, right? The failure tolerance, like that. So they are non-functional, right? And we consider security, protection, right? And difference between culture, they are all non-functional, but even more important. I said more important. That means based on your function, right? So you should have function, of course, right? So we said that we have key value. Based on key value, then we have different kinds of NoSQL data, data type. Right. So we kind of finished that. Right. So we talk object persistent formats. Then we talk about the mapping, how to optimize it. And last, we mentioned a little bit non-functional requirements. Okay. And of course we talk about V&V, right? Verification, validation, right? So about a V&V, here it is. Validation, verification, right? When we talk about system planning, analysis, and design, all right? So validation, V&V, which one we talk the first V and which one is the second V? Which will be the first and which will be the second? Alex? Okay, Alex, which will be the first?
First is do the right thing, and the second is do the thing right.
Which one is a validation? Which one is verification?
First is validation, I think.
The first one is a validation.
Yes.
The second is verification. So it's a do the right thing and do the thing right.
Yes.
And you can see this verification. It's verifying and validating. Verifying and validating.
So we're gonna switch it. His verification is the first, and validation is the second.
No. No. Someone wanted to explain this. Let's come to you. Which one is the first and which one is the second?
I think we have to first we have to do validation.
Validation?
Yes.
Do the right thing or do the thing right?
Do the right thing.
Do the right thing is a validation, and then do the thing right as a verification.
Yes.
Now look at this. Verifying and validating. It's the same or different? So here, verifying and validating the designs of data management layer. So verifying, validating, and change makes the problem to me. Would you explain that? Is it wrong or is this wrong? Or they are different? Yeah, it's not easy. Positive. Can you explain that, Fraser?
Verification, and it represents the do the thing right.
So which one is the first? You agree with Carol? Validation comes first and then verification.
Verification comes first.
Verification the same as Alex. Verification comes first and then validation.
Yes, and
So do the thing right comes first
yes,
and then do the right thing.
yes. Then do the right.
Yes, you fail. No. You say yes, then you fail. Of course, we should do the right thing, right? Do the right thing, then do the thing right. If we choose the wrong direction, no matter how good, the way you go, then it's wrong, right? So do the right thing and then do it right. Validation. You plan it. So planning is the most important, right? Do the right thing. If you plan it wrong, no matter the rights you have done, then it's wrong, right? Do the right thing and do it right. If do the wrong thing, it doesn't matter, So that means that your precondition, precondition is wrong. Then the result is wrong, all right? Post-condition, it's wrong, all right? So if your precondition is wrong, then you got to strengthen your post-condition to evaluate. No, then we change, all right? So validation goes first, then verification. But here, verifying, and here it talks about different thing, all right? So now we go into verification, right? So we have the right direction, we have the right requirements. And when we design that, sometimes we need to change, all right? But it is on the right domain, that's correct. When it is correct, and now we probably wanted to change that. So you're verifying, so we got to make sure, right, the function, right, verifying, because now we already passed this, and go to design, and design. Okay, yeah, that is the function where you wanted to change that. Then validate it. Make sure it is correct. Correct function. So let's say that we wanted to conduct denormalization, right? We want to conduct denormalization. That's verify, right? So yeah, we wanted to conduct this. We wanted to merge that, right? Or to add some attributes to different table. Yes, we'll do it, verifying it. But is this necessary? validate it. No. We can do it, but no, because it happens sparsely, right? So validate it. So you're verifying and validating any change made to the problem domain. All right. So yeah, that's it. Yeah, this is about this chapter, and to finish all the lecturing. Get a question? Oh, I think about your teamwork, right? About a prototype. You need to report your prototype, right? Report your prototype. If there's a print, right? Print, you don't have everything, right? So you probably, with some friend, describe your system. That's it, right? Because you need to demo and explain your prototype on site, right? So your print file, depends on, you wanted to describe it a little bit. You don't put very, very detail, all right? It's a waste time to do it. Okay, any question for now? You know that times for your quiz.